really, you to tell me what you don't understand, right? Because if I was to take lead, probably that would mean me going through all the slides, and we don't have time to go through all the slides, right? What we have time to do is for you to tell me the parts that you don't understand. You understand? Tell me what you don't understand, so that we can basically directly target those items. Like I said, if I want to go, I'll probably be bouncing here, there, and everywhere. You understand me? And when we finish, we haven't cleared up everything. So if you tell me where you have the problem, right? We can go directly. We can go directly to those. Right? So where we have the problem, anybody? Let's start with anybody.
Sir, me
I'm here at the beginning.
That's all right. Remember you got one in the formula, which is W times T over big W, right, sir? And they got when you get this out of formula.
Another problem. The diagram before you, right? The diagram before you guys. You guys understand the diagram? You guys understand what is happening?
Yes, sir.
Who doesn't understand what is happening? Who doesn't understand what is happening with the diagram? Speak no for your morning, alright? See one portion that doesn't understand. Alright, good. So basically what is happening is that initially this vessel is like this. Right? When this vessel is like this here, you have the center of gravity passing straight. You have the center of gravity passing straight through the center of the vessel. Because this vessel is perfectly balanced. You understand me? Now, the issue is that what happens now is that we put a load here. You understand me? And because we put a load here now, it causes this here to shift a bit. You understand me? So ultimately, when we have this shift here, we're going to have something like this here. You guys all understand how I get this broken diagram, you know?
Yes, sir.
The reason why I get the broken diagram is because I put a load here. And because I put a load here, I'm gonna leave. You understand me? Now what happens there also is that the center of gravity, which was here, you understand me, is gonna shift at the same time, because guess what? The vessel shift at the same time. The center of gravity is gonna shift and try to balance back the vessel. Well, it's gonna try to balance the vessel in this leading direction here. You understand? But guess what? There is something that is trying to oppose that movement. There is something that is trying to move that vessel back into the original position. You understand? But we haven't been there yet. To every action, there's an equal and opposite reaction. We know Newton's third law of motion. You understand? So there is something that is trying to move this vessel back, right? So when I speak about clockwise direction, I mean direction moving here. Right? When I speak about anti-clockwise direction, I mean direction moving here. We know that. Or I assume it too.
Yes, sir.
Yes, right? So these are the terms that I want you guys to use in the exam. You understand me? Clockwise direction, anti-clockwise direction. Clockwise moment, anti-clockwise moment. Right? Now, when we speak about this GGH, right? There is because this vessel was like this. The vessel was like that, right? Perfectly like this here. Perfectly like this here. That was the vessel. You understand me? Now there's a slight movement from here to here. You guys you see that slight movement? Right? Now, who can say this angle here, the angle of movement is what? Is equivalent to what?
Clockwise.
There is a distance there that we would have moved, right? You guys see that distance there? This distance here. Right? The because we were like this here, originally, we moved like this here now. There has to be a measurement between where we were initially to where we are. Now that distance is transferred here. You understand me? Because this movement here causes this movement here. Originally this here was the center of gravity. This here was the center of gravity. Because we have a shift from here to here, that shift in itself has to be reflected here also.
Yes, sir.
If I get this A, and I move the top, the bottom movement, right?
Yes, sir.
Can you understand me?
Yes.
So this topward movement here is reflected by this movement, here. So if we calculate the length of this movement here, it is the same length in this movement here. You understand me?
Yes, sir.
What happens there now is that when you have that movement here, the displacement of the vessel, you understand, or the measurement of the vessel is shown. If it was 9 meters, it sinks deeper in the water. You understand me? It moves from 9, it goes to something like 15. Let me call it 15. Right? So there is a movement in distance, or there is a movement in depth of the vessel from 9 to 15. Right? These are just figures that I'm calling so that we can have a better understanding of what is going on. Some people look lost. If anybody is lost, let me know. I'm trying, before we go into the technical part, we gotta understand this diagram here. We gotta really visualize what is really going on with the diagram. Right? So the GGH that you're asking us to calculate is that movement. Is it from here to here? This here was the original center of gravity when this here was perfect. You understand? This here was the center of gravity. Now, it's not perfect because of the additional load. You understand me? There is some less. You understand me? Because there is some less, there is movement above the center of gravity. This here is a movement above the center of gravity. Right? They ask us to calculate the angle of this. This here basically is the angle of this that we're calculating. This is basically what we're calculating. And in most cases, the only reason why we can use the sine rule and the cosine rule and the tan rule is because of what? Because it's a right angle triangle. If it wasn't a right angle triangle, there was no way we could have used it. Right? But because of the standard of the problem, in most cases, well, in all cases, it's going to always be tan. You understand? Because of the standard of the triangle. Right? Tan caters for the opposite, that is the side that is opposite the angle. The angle is going to always be here. You understand me? And what we're going to have to calculate is going to always be here. You understand me? So tan caters for that. Right? So in most cases, in all cases, we're going to have to use the tan ratio. Anybody doesn't understand? Everybody with me?
Yes, sir.
All right. Somebody sit on your seat and click the change the slide on the key. Anybody? Designate click on this. Put the cursor on the slide itself to the side. On the second slide. And then it's gonna put the cursor here. Click on So this here is the original position. We have the center of gravity and the center of buoyancy on the same axis. One is acting up and one is acting down. Right? And the reason why one is acting up and one is acting down is because the two needs to cancel out each other. You understand? Right? So when we apply the load, the load causes the shift. Right? The left it or the right? Oh, somebody left the phone. Somebody left the phone over there. Good. So we understand this diagram, you know, right?
Yes, sir.
Go to the next. This is a formula that somebody said you understand. Who
Yes,
doesn't
sir.
understand the formula?
Sorry, just this here and the other formulas. It's two different questions, right, sir?
Alright, so what they're saying here is that W is a weight shift. Right? That's a weight of the object. That's W. Right? D is the distance through, go back to the previous slide. W is this weight here, right? D is the distance through which we have the shift. You understand me? And big W now is the displacement. You understand me? Now displacement is a function of something. You understand me? It's important that we understand the difference between weight and displacement. Just like I explained to you the difference between weight and mass the other day in class, we need to understand the difference between weight and displacement. Because some of you are going to use the same value for weight as displacement in the exam. And if you do that, you're going to get it wrong. Right, so somebody who was following in the class, go back to the formula, please. When we speak about W is the displacement of the ship, which includes its weight. Can anyone see what is this W that we're talking about?
Sorry, where's the object?
So is the distance in which the weight move or whatever?
W is the displacement of the ship.
Sorry, the big W is basically the entire.
How much water
There's how much water the ship displaces, right?
Yeah.
No, the ship is going to displace some amount of, or some tonnage of water. And because it displaced some ton of water, it means that the ship was submerged some distance in the water. You understand me? So it's basically, the displacement is the weight of the ship, you understand me, multiplied by the amount of water that it would have displaced, or the distance of the amount of water it would have displaced. Alright, listen to me.
Sir, including the weight that was
Alright, let me see how we see. If we have a vessel that's weighing 5,000 tons, you understand me? The depth submerged is 5 meters, right? And then we put on 10,000 tons more. You understand me? Of course, we're going to get a new submerged depth. You understand me? So the displacement now is that weight multiplied by how much more we would have submerged. Displacement. So that's why they say displacement, distance. You understand me? The distance is how much we move. You understand me? But that distance must take into consideration the weight. You guys understand?
Yes.
No, some people still don't understand.
So this is
One more
the
time.
ship including the
Displacement, listen to the word. Displacement, distance. What distance we're talking about? The distance of the keel. How much deeper in the water the vessel goes. That's a displacement. You understand me? So the displacement now is the weight of the vessel taken into consideration of the added weight added to the vessel multiplied by that distance to which the vessel would have submerged more down in the water.
No, understand, sir. Understand, sir.
You all understand?
Yes, sir.
Who say yes? Emily, explain. Explain, let me hear what you understand.
I understand that the displacement of the ship is the distance of the view from the water line
Uh-huh.
to the keel, include that is caused by the addition of the weight.
The addition of the
to
weight.
ship's
All right, thank you,
weight.
Jesus. So, this here is the vessel, right? This here is the water line, 5 meters. You understand me? The weight of this vessel, 10 tons. Guess what? I add 5, no, let me use 5 again. 2 tons more. You understand me? If I add 2 tons more, this here can remain 5. Can remain 5. You understand me? The addition of that 2 tons caused the water level to go, let's say 8. You understand me? The displacement is this load combined multiplied by this distance between here. The change in this. And let me say that change now is 3. So it's gonna be 12 multiplied by 3 displacement.
Roger, sir, Roger.
You guys understand?
Yeah.
That's what it says, which includes the weight. If we didn't put the weight in here, you understand me, the displacement is wrong. If we don't include this addition, because it is this additional 2 tons that cause us to move an additional 3 meters. You guys understand that?
Yes,
If we remove this additional 2 tons, you understand me? There is no movement, we still remain here at 5. You understand me? So that's the reason why we must include the additional. Right? This here, the displacement presently is going to be 10 multiplied by 5. You understand me? That's the displacement. Now we put on the load, on top, you understand me? Remove some inches more. This is wrong. Sorry, this is wrong. This here should be 8. Right? It should have been. You understand what I said?
Yes, sir.
Sorry, anybody understand nothing? Right? So we move to 8. So we gotta include this distance here, the distance from here to here, and then we gotta include this one here too. So this here was 5, this here is 3, so we have a total of 8. So the displacement, go ahead.
Sir, what unit you answer here?
The unit?
Yes.
But I wish you could tell me now. Because remember you answer got be in a unit. If you answer supposed to be in meters and it will be centimeters, you better say sure it be the equivalent. You understand me? The number is the equivalent. You understand me? If your answer is supposed to be in meters, 100 meters, but use a right by, you want to answer in centimeters, right? You are giving 100, what is the equivalent of 100 meters in centimeters? The equivalent. You understand me? You can't give me 100, you can't give me 100 centimeters too. Because that's wrong. Andrew? This is wrong, right?
Yes, sir.
You gotta tell me, you gotta write down 1 meters is equal to how much centimeters. Therefore, 100 meters now is equal to however centimeters. I mean, you gotta write it down like that, but you need to give me the equivalent. You understand? Because we would know, everybody would know here, that 100 meters could never be the same as 100 centimeters. Right? So it means that we're misleading everybody. Can we move on to the next slide?
Yes.
Yes, sir.
Good. So this formula, some old horses can always hear their owners approach. Right? So the issue here is that if we want to use sine caters to the opposite, but it's actually hypotenuse. You understand me? We don't have the hypotenuse. Alright, so we can't use this here. Cos caters to the adjacent and it's actually hypotenuse. Those two values are irrelevant to our problem. Right? But tan now, it caters to the opposite, it acts to the opposite. However, we have the adjacent, right? So we can move on. Anybody has a problem with any of these here?
No, sir.
If you get a problem, just remember in the test, just use this one. You understand? Just remember the test you gotta use. Right? So we understand that this initially was our center of gravity. We understand this here, right?
Sir, it's not a broken line, it's our original center of gravity.
Sorry. No. This here is the original one.
Sir, the thing is that GH is the new, position of the center.
Sorry. My apologies. Alright, so this broken line here was original center of gravity. And there is a shift. What kind of shift we got? We got clockwise. We have a clockwise shift. Right? And because we have a clockwise shift, there is an opening somewhere here. What is the angle here? It's supposed to be the same as this here. It's supposed to be the same as this here. Angles on a straight line is what? 180 degrees. Z angles, this here and this here, same thing. Opposite angles are the same. Alright, this is just some extra classes we're doing, right? Good. Who doesn't understand this formula here? Tan theta. Let me ask a question now. What calculators are you using to write this exam? You can use your phone, right?
Sure.
Or you can use a calculator that you're just using the shop. Right? No, because it doesn't have the tan function on it.
Oh,
The regular calculator doesn't have the tan function on it.
Scientific.
So you need to use a scientific. Who doesn't understand how to get the angles on the scientific calculator? So everybody understands that, right?
Yes, sir.
So they say tan theta is equal to GGH divided by GM, right? We know that GGH is equal to what? Small w
Times the.
And if you write W like this here, and then write W like this here, I'm going to be a little confused. You understand me? So I prefer you write W like this here, you understand me? Give it a little curve, and then you use this one. So I know the distinction between the two. You understand me? If the student for some reason write the two together but uses the wrong value, you understand me? He can get it wrong. But if the students give me like this here, and use the same value here, you understand? I'm going to get it wrong. If the student gives me it like this here, but for some reason still use the same value, I can flex. You understand me? And the reason why I can flex is because that gives me an indication that the student knows the formula. You understand me? It's just that the student do something and they use the wrong value.
Yes, sir.
You understand? So we can flex because like I told you guys before, I am not marking for the answer. Marking for steps and formula. That is what I'm marking. You guys understand?
Yes, sir.
So you can give me the wrong answer, but once I see that you were following the procedures and where a negative sign is supposed to go, you put a positive sign. You understand me? We're going to flex. We're going to flex. Alright? We know how to calculate our GM. Right? We know how to calculate our GM. The formula for GM is what? Km minus some kg.
Yeah, K minus K.
So tan theta is going to equal to this here all over Km minus Kg. You guys agree with me?
Yes, sir.
No? Anybody say no? Everybody understand?
Yes, sir.
Because GGH is this part here, and GM now is this part here. Alright, so it's basically it's the same to be writing back, but all we do it is that we're writing it back in expanded form. You guys agree with me? Same thing, but just expand it. Anything on this slide that you guys want to understand?
So please move back there, please.
Which one?
I just stepped out, so.
Alright, not a problem. What we're saying that tan theta is opposite over adjacent, right? So if tan theta is opposite over adjacent, we know that opposite now, which is this part here, which is GGH, right? Because we need to calculate GGH, and we know that the formula to calculate GGH is small w, or weight, divided with weight multiplied by distance, and don't put the x here. Do you want to see this?
Yeah, sorry.
Alright, don't put the x. Alright? I know that WD is the weight multiplied by the distance. I already know that. No reason to give me x. Right? Some lecturers, when they see x, is basically telling them to multiply it again, which is wrong. Alright, so don't put the x. Once I see WD, you understand me? I know that this is the weight multiplied by the distance divided by the displacement. Right? This is the opposite. WD over big W. This is the opposite. And I know the adjacent is kg minus km. Right? So basically, tan theta is equal to WD divided by big W divided by km minus kg minus km. They just expanded form. Right? I mean, you don't have to show me out. They say if you want, you could work out your little thing up in the car and everything, and just take your values and plug it in. Right? If you give me tan theta is equal to opposite over adjacent, right? You don't have to tell me that opposite is this same and adjacent is this same. All you need to do, drop your value here and drop your value here, and we good to go. If you want, you can do that. However, if your value is wrong, you haven't given me anything to justify to tell me that you know how you get your value here. If you understand. This is what I'm saying. Let me say you calculate your opposite and your opposite is 5. You calculate your adjacent and your adjacent is 2. Total 7. We call it 7. So you give me 5 over 2 is equal to 7. But guess what? 7 is wrong. You understand? It should be a much smaller value. Let me say the answer. The answer should be 2.5. Right? What is it is there? You understand me that I'm gonna say, oh shit, get the wrong number. But let me see what really do forget this 7. So I could at least give you something, give you a thing. What is it there I can use? Can't use nothing. Right? Because you just tell me opposite over adjacent is equal to 5 over 2 is equal to 7. Right? So the student now who's going to tell me opposite over adjacent is equal to this here, divided by this here, and then equal to 5 over 2, which is equal to 7, you understand? I mean, like I said, well, all right, the student know what he was doing, it's just somewhere around the line, they just use the wrong value. You understand? They know the formula, but they just use the wrong value. And that's the reason why I'm allowing you to go in with the formula sheet. Right? So there's one less thing you need to focus on. You don't have to kill yourself unless the formula isn't on the list at MD. Right? If the formula is not there, go beyond there.
Best of luck.
Alright, but remember the formula is one less thing that you have to worry about. Alright, can we move on from this here?
Yes, sir.
Excellent. Alright, so do we understand? Can anybody say what is going on here? What really happened? No, the weight, what happened is that the weight would have caused a shift vertically and horizontally. Horizontally, in this plane here, and then it would cause a shift vertically also. So that's why they end up with this here. Vertically downward, horizontally across. Right? Horizontally across, vertically upwards. However, it doesn't even matter if the triangle is upside or downside. What is important is that the diagram, you get the right diagram. You understand? Because you would agree with me, the distance here to here is going to be the same distance from here to here. The distance from here to here is gonna be the same distance from here to here. You understand? The only thing that you gotta focus on is that when they say the ship is vertically downward, your value must have a negative sign. You understand me? So when you're tabulating it, you understand, you have to remember to drop that negative sign on it. Include the negative sign. That's the only thing you have to focus on. Of course, when they say horizontally, it doesn't matter if it moves to the right, it doesn't matter if it moves to the left. It's always a positive. Right? However, if they say vertically upwards, you keep it as a positive. If they say vertically downwards, that is where the problem is. You understand me? Vertically downwards, you must put a negative sign on that value here.
So the value would be negative then?
This value here is going to be a negative. Alright, this value here is going to be negative. Of course, this value is going to be positive. This one is a positive. This one is a positive also. And we work problems like this here. Already. You guys remember that?
Yes, sir.
So anything here that you guys don't understand.
So you can give me an example on how we work it?
Yeah, man, we work a problem, but we don't want the problem again.
Yeah.
We work a problem. Slide. We know this here. We know this here, right?
Yes, sir.
Slide. Slide, we know this here. This is the problem. Ship initially upright has a displacement. It has a displacement of 12,200 tons, kg, 6 point whatsoever, km, that figure here. A weight of 40 ton is in the lower hole in a position kg, right? To port of the center line, calculate the final list. If the weight is shifted to a new position on deck kg, 11.4 meters, 2.6 meters, the starboard of the center line, right? Now, if I remember this problem here, it had some problems that when we put it in the table, right? We took the same displacement, or final displacement what was given in the problem. We took that as our final displacement. Now we had some problems now that when we put the values on the table, we had to go and add up all of those weight and then use the final displacement. You guys remember those problems? Yes, sir. Now the reason why we had to do that is that 40 tons, they give us 12,200 tons, and then an additional 40 was added. So in this case, we can use this here as the final displacement. You understand me? We can use, if the blank put this 40 tons from the problem, take out the 40 tons from the problem, you can go ahead and use it. You can go ahead and use it, well. You understand me? What is that? Go ahead.
For me, right, looking at it, like, how you know that it's different because it's a displacement of, and it's saying, no, with 5 tons, a weight of.
Initially. Well, the problem in itself is supposed to tell you that this here can't be the final one because 40 was, an additional 40 was placed, a weight of 40, right,
But
in the
it
low hole.
didn't say that the 40 was placed, it just said the 40 is there. It said that the 40 was shifted to a new position.
Okay, let me go to the solution.
Sir, question. So usually, right, when I see your questions, if the question get initially, that means it's not the final. Initially is usually the first thing that it gives.
Mm-hmm.
So if it get initially, usually it's not the first.
All right,
That's not the final.
go back to the problem. Go back to the problem. A ship initially upright has a displacement of 12,200 tons, kg, or whatever it is. A weight of 40 ton is in the lower hole in a position kg and 4 meters to port of the center line. Calculate the final list if the weight is shifted. Calculate the final list if the weight is shifted to a new position. Okay, I understand what Emily is saying. The 40 ton is already considered.
Yeah.
Is already considered in this displacement here.
If it's
You understand me? So the only thing that they did know is that they took 40 tons down and shift it to a new position. You understand me? So it is already there. You understand me? So now all what they're doing is that they're shifting it. If I'm right, Emily.
I understand.
Yeah, you're right. You're right. So the 40 ton is already considered in this displacement here. You understand me? It's like we hear the total classroom is 12,000 tons. But this table here with these three portions is on the port side, and we take this table here and we shift it to the starboard side. Right? We shift it some distance to the starboard side. You understand me? And it's going to cause the vessel to react in a certain. It's going to cause the vessel to react in a certain. Right? And because it's going to cause the vessel to react in a certain way, the problem is asking us to calculate that reaction. You guys understand?
Yes, sir.
Next slide. Right? So, why are we calculating GGV? Normally GGV is calculated.
Yes, sir.
Probably we calculating
Working
GGV
with shift
because
and
it moves not only downwards,
One
but
is
it moves.
horizontal.
It moves downward, there's no vertical.
So what is the problem, you see?
GGH is the horizontal.
So it
GGV
moved
is
from the
vertical.
lower hole to the deck, so it
Correct.
gone up 40.
Exactly. Right, so in the problem it said that a weight of 40 ton is in the lower hole in a position of this here, to port of the center line.
Port.
Calculate the final list if the weight is shifted to a new position on deck kg xyz to starboard of the center line, right? So the lower hole is the indication, right? That we need to calculate the vertical, right? Go back to the solution. So we know this, right? My advice to you, one of the first thing you need to do for the problem, just calculate this thing. You understand? If they've done an ask you, just go ahead and calculate. It's probably going to be good for you. We know how to calculate this thing. Right? 11.4 minus the 22, minus the 2.2. Anybody know what we get at? As a distance?
So the 2.2 was in the on the lower hole. Then when it shift, the new one is going to be 11.4.
Exactly. Right, go back to the problem. So what they say here is that a weight of 40 ton is in the lower hole in a position kg 2.20 meters, right? 4.0 meters to port of the center, 4.0 meters to port of the center line. Calculate the final list if the weight is shifted to a new position on the deck, which is 11.4. You understand me? To the new position. So the first thing that we need to do is to calculate the difference in shift. Right? The difference in shift is this one here. You understand me? And this one here. Go back to the solution. So we have the difference in the shift. You understand me? It was initially at this here, and then we move it to this one. Right? So we can't add the two. The difference is going to tell you the exact distance it would have moved. Right? We know where the 40 came from. We know where the 12,200 came from. And we calculate it here. Right? Initial kg minus the GGV, and the only reason why they put it up is because it was vertical. Right? We minus it, we have the final kg. Right? The km, if I remember exactly, the km was given in the problem. Right? Sorry, we added. This is good, you say add at least I know you have paying attention. Right? So the km and the final kg, the km and the final kg, we minus the 2, right? And we get a final gm. Right? If nobody understands so far, let me know. This is the easiest part of the problem. And we know why we need to find the GGV, and we know why we need to find the final GM. Right? Why we need to do that? To find the list. The problem asks us to find the list. You understand me? And we know the formula. Next slide. We know the formula is that the list now is the GGH divided by the GM. Right? However, we need to go and find the GGH.
Sir, find the GGH. Not the GGP.
In order for us to find the GGH, we had to find the GGB. The formula tan theta is equal to GGH.
Sorry,
You understand me?
The cargo go up and then to the starboard side.
Correct.
Make that the boat.
Exactly. The formula, remember the formula is GGH, not GGB. Not GGB. Right? So it doesn't matter if you get vertical shift and horizontal shift. You understand me? Always remember the formula is GGH. You can't take the GGB and put it here.
So this part ain't changing though, for the weight.
This part is changing also.
No, the part, because when you calculate it with GGB, so.
No, this part isn't changing, but this distance here is changing. You guys understand the distance changing?
Yes, sir.
Right? So the distance changes, W remains the same. When W remains the same now, we have GGH now divided by the GM final. Right? Now we have the GM final. Mind you, right? The formula is GM final. Right? If you go back, please. We get a GM final here. We get a kg final, and then we have initial kg. You understand me? So in order for us to calculate the final kg, the final kg was the problem is what we didn't have. You understand me? And in order for us to calculate the final kg, we needed to calculate the GGB. You understand me? We calculate the GGB now, we get the GGB, which is this here, and the final kg now is the initial kg, plus the GGB is going to give us the final kg. Now we want the km. You understand me? The km now is the final kg, which we just found here. You understand me? Minus the final, what's it? The km minus the final kg, which this is the final kg. You understand? And then we get the final GM.
Basically, I use the GGB to find the final CM.
Exactly. Exactly. And this is based on the problem, the dynamics of the problem they give us. In some cases, we don't need to go and calculate no GGB because it would have given us enough information in the problem that we could have gone straight and find the GGH. You guys understand?
Yes, sir.
Good. I like the yes, sir. I don't want some more complicated. No, go back to the answer. So now we have the GGH divided by the GM final. We get a value, and when we get a value, like I said before, second function tan inverse is going to give us the angle of this. Right? Next problem. Alright, so if a weight is loaded or discharged, then both the vertical and horizontal component of the ship of G must be considered, and the final GM must be used to calculate the final list. Right, so this is what our diagram is going to be looking at. Alright, we get a downward, if we get vertical shift, right, whether the shift be downwards or whether it should be upwards, this is what it's going to look like. In this case here, the shift is downward, the shift is up. So we get a vertical, understand, and we have a horizontal. Right?
So on the exam, you giving me these diagrams? Or we gonna?
No,
You
man.
got
You guys
So how much marks on this question will go?
Like
At 15, right?
8 questions. 8 questions, you need to answer 6. Alright?
Sorry.
And some of those questions, I believe, 8 questions you need to answer 6. 2 questions or 3 questions are going to be compulsory. And the rest, you choose nearby.
Sorry, yeah, I ain't got the accurate, like.
The drawing,
So if you got look good.
the drawing doesn't have to be artistic.
So it could be a sketch like the
Sketch. You understand? The drawing doesn't have to be artistic. You understand me? But you can't get a wrong drawing and get it right done. So, me understand if you're doing that.
Sorry, how much you going out to?
How much the test going out to?
Yes.
I see some students who are asking for the course for a grade. Right? The mistake that I made initially is that I thought your 10% course, your 10% grade, right? That we're going to play with. You know, the midterms is 40, and then you have a 10%. the mistake that I made initially is that I thought that 10% was strictly assignment basis.
So you
But-
correct it already?
Yeah, I correct it already. Each student, nobody's going to go in with less than 7 or 8, right? Because it's difficult for me to assess you guys online really. You understand? The mistake that I made with the assignment I was telling these guys is that marking 90 something assignment or 80 something assignment. It's easy. You understand me? It ain't easy.
Question, sir.
Uh-huh.
So you ever read the bio?
It's like
Yes, sir. What happened?
None. I tell them the same. I tell them none.
So you know I went up one night right here?
Yes, sir.
That was pressure.
The bio.
Sir, you particularly said that I gonna reach you each and every one of these by you. So I was like, alright, but I gotta put this, make sure this thing accurate.
When I go into the email and I see 93, I said, what? You understand? So I was telling you guys I should have given you guys group. Or with the bio was just so practicing for us a little bit. You understand me? But for the assignment questions themselves, I should have really put you guys in groups, probably put you guys in groups of 10. You understand me? And give you the question.
Well, sir, the bio should come as a part of the exam too, you know. For 5
No, but
marks.
I'm giving you the marks, I give you the free marks out of the 10. I give you that.
Every time?
No, I can't give you 10. Listen to me. This is my policy. You just can't get 10. Just can't get 10. You can't get 10 because I got keep one for me. One is for me. So basically we're going out to a stage going out of.
Alright, I accept it. So,
It's
no problem.
basically, you can't get 10, man, I get in 10.
So you miss class?
You can't get 10. Can't get 10. You telling me no mistake you make this, you telling me? No man, no reason to play it. You can't get 10. And I gotta keep on for yourself. So basically you just walk away with me. Good. So if a weight is loaded, G will move directly towards the center of gravity of the load. And we understand this here. You understand me? The center of gravity is going to take position on the load. You understand me? And not necessarily it's going to take center of gravity on the vessel. So it's going to take the center of gravity on the load, considering the weight of the vessel. Right? Good. Now if a weight is discharged, G will move directly away from the center of gravity of the discharge weight. Right? So because it was loaded, or this is the vessel, I is the vessel, you understand me? Now the load was the vessel was loaded with an additional load, so I shift my center of gravity here. You understand? So my center of gravity gone here. Now if you remove the load now, you understand me? I shift back to the original.
Sorry, you can't go directly back if you look at this, right? If you put weight on this, and it's got on, so you release it, the weight is going to go back with more than the center of gravity.
Can't go back.
Sir,
Newton
sir, if
laws.
you didn't want to, sir,
No,
think
man.
about this, sir.
If you tell me that, Isaac Newton is a dunce.
No, sir, you can't take
Isaac
this,
Newton
right?
said equal and opposite. To every action, there is an equal and opposite reaction. You understand me? So if I add a load and the load causes, if I add a load of 1,000 tons and it causes a shift of 10 meters, equal and opposite to that is if I remove that same load, it's supposed to go back the same distance.
Sir, not like right away, sir.
You have believe in me or you have believe in Newton?
Sir,
I
no.
was taking do something for the exam,
Come on, you
sir.
should like that to do that Sunday.
Man, I wouldn't even argue with you
Sir,
today.
no, you don't want to, right?
Alright, when I come to work on Monday, you come to the office and you explain that. We will never argue with that. Good. So now, the reason why we can get a plus or minus, anybody can say why we get a plus or minus? Plus or minus W.
The direction.
Exactly. So the plus or minus consider whether the weight has been added or whether the weight has been discharged. Right? Remember I told you the weight has been taken off, we gotta use a minus. If the weight has been added, we gotta use a plus. Right? So that's the reason why we have a plus or minus. Right? We know this formula here. Easiest formula on the board. Next slide. We know all of this here. Good. A ship initially upright displaces 6,400 tons and has a kg of 4.6 and a km of 6.5. A weight of 80 tons is loaded on the deck at the key chip XYZ of the center line to Star Road. Calculate the final list. Go to the solution. Right? In this case, we calculate, we went and we calculated the same thing that we did, come quiet on this. The same thing that we did, the initial problem, we do the same thing here with this problem. Is there anything that you guys don't understand in this problem here?
No, it's
Go back to the question.
I read it.
Yeah, this one.
Good. And a weight of 80 tons is loaded on the deck. Right? If the weight is loaded, you understand me? You get a vertical displacement. Or the ship is gonna be submerged deeper.
So I see this one formula now it's gonna be too small W then basically. This so the weight.
Well, me why is a too small, me why is a too small W. The reason why me why is a too small W, you understand me, so you're going to be confused there.
Remember, I don't think it's too small W because remember the GGH, right, in the formula is one is the center of gravity and the other one is the vertical GGV, I mean, one is the vertical rise and go down. So you calculating the distance, and the only thing that causes the distance is this extra weight, not a prior weight. So it's only one small W, because it's the one small W that causes this vertical rise or fall.
Let's go to the solution. Let me see if we can understand what they did with the solution. Alright, so you have 6,400 plus the 80. Right, go back to the problem. A weight of 80 ton is loaded. It means that 80 ton was added. In the previous problem, the 40 ton was already on the vessel when they calculated the displacement. The previous problem, in that 12,200 tons, you understand me? They said that the displacement, that 40 tons, it was already on the vessel. The only thing that we did with the 40 tons is that we move it from one place to the next place. You understand? That was the previous problem. In this problem here now, they said that the displacement, initially we have a displacement of 6,400 and then we went ahead and we loaded. We went ahead now and we load an additional 80 tons. So you guys understand the difference between the two problems?
Yes, sir.
Yes, sir. Right, we loaded 80 additional tons. We just didn't move it, we just didn't go and meet the 80 tons there and move it left or move it right. We went and loaded. And because we went and loaded now, you understand, it causes the vessel to submerge more deeper in the water. So it means now that our displacement gotta change. The displacement gotta change. Right? So go to the solution. So what is saying? The displacement in the formula that we discussed, they say the displacement must consider the weight, or they said including the weight. Remember we read that?
Yes, sir.
Including the weight. You understand me? That's why we went and we included this 80 here. You understand? So this here is the total displacement. Or this is the value for the new displacement, considering the new displacement. Why we didn't use the small w again in the previous problem is because there wasn't no new displacement. It was already there. You understand me? It was already there. You guys with me?
Yes, sir.
Good. So now, simple, we calculate our GGV. We know this formula here. We know this formula here. If you guys need anything else, if any student that I see get this thing around, something happened to them. You understand me? Something happened to them. Any student that get this formula here wrong or get the value for this thing here wrong, if you get not right, get this here right. I'm begging you.
So I hope you'll be like, lecture was said and bring it and then I bring it when it comes. That's what happened to me right here. Instead of this coming out when you see the paper, it's something else.
I'll tell you this. So I was sitting last night and I was trying to change up the same problems from the work that we did. You understand me? We'll bring it back. You understand? But it's hard to do it.
So
That's the same problem. We can't hear the same problem.
Sir, I mean, sir, in all logic, sir, in all logic, sir.
We can't tolerate though.
No,
You understand?
sir, this is understandable, right?
And then we get cousin one enroll in the program next year. You understand me? I said, but we don't want them. You understand? Can't tolerate that.
Sorry, that logic though.
Can't tolerate.
All of this is gonna basically be used on a computer.
Basically, the two, let's say this, the two problem that is going to be compulsory is mu. Is mu. Right? And the remaining problem that you got to choose from is u.
Is that like we created these problems?
No, I'm just creating the two. The two is two new problems. Those are belongs to me. You understand me? The remaining problems belongs to you. It's problems that more than likely you probably see before with minor changes to it. But the two is me you never see before.
How much you go?
Everybody went for the same mark.
Alright. So if I answer all, sir,
Let me just.
No, if you answer all in the exam rules, you know, just take the first, if we give you 8 problems and I say I got you 6, the first 6 I give you, the first 6 I mark it. Anyways, if you never answer for mark 8 problems, it's time. It's time. Right? So if you want to do all 8, you just ensure that the best 6, they're the down.
sorry, let me last.
No, sorry, the test is going to get 2 sections, right? The compulsory section, and then choose the remaining. Right? Choose the remaining.
That's what they say, so I put you two compulsory at the back.
It doesn't matter if you want to walk the paper from the back to the front, you could do it any way you want to do it.
Sir.
You could do it any way you want to do it.
Understand this here, right? But
Uh-huh.
generally, right, you said that the big W, right, is the displacement of the ship plus the
Wait, are they?
Considering the weight of the object.
Right?
Uh-huh.
Sir, how you put this thing here, right, with big W plus little w is basically what I see here, right? I understand this question and what you did, right? When I first look at it, what I see is basically the initial displacement of the ship plus the E, and you're telling me for add an E. This is how I see it when I first look at it.
No,
If you understand
but you seeing it different now?
Yeah, seeing it different.
Okay. In the previous problem, they said that the displacement was 12,200. However, there is a bag of sand. There's a bag of sand in one of the cargo hold, and that bag of sand was at 40 tons, right? At 40 tons on the starboard side, right? So what they say now is that they took the bag of sand on the starboard side, and they took that same bag of sand and put it on the port side now. So we just shift it. It was always there, and the displacement of 12,200 catered for that 40 ton of sand. In this case here now, what they're saying is that guess what? All the cargo holds are empty. You understand me? The weight of the vessel is what? Is 6,400? 6,400. But Jones come from somewhere. You understand me? Jones say, hey, let me drop 80 tons more onto this vessel. And if Jones do the note, we have to calculate a new displacement. Right, so you guys understand that?
Yes, sir.
Good. So we have the new displacement. So we went ahead now, we calculate our GGB, right? Then we see our initial kg, right? Plus the GGB is going to give us the final kg, right? And then what we say now is that we say the km now, you understand me? Minus the final kg now is going to give us the final g. Just remember the steps. Well, y'all have the formulation, so y'all will know, right? Next slide. When we done that now, we did all of that to come up with this party. You understand me? To come up with this party. Now we need to get this party. Like I said, tan theta is going to always be equal to GGH.
So I have a question. So everything GGB down, minus it?
So the GGB down is minus.
Alright.
Right? Good. So we have this say GGH, we calculate our GGH using this here. Same thing, right? The only difference is this here. This is what changes our problem, right? We calculated it, we get this value here, and theta is equal to GGH over final GM, we get that. Easiest part. Mind you, the problem won't come like this. This is just part A of the problem. You understand? You can't get for simple problem like this. You're going to be looking like a fool.
No, man, sir.
You can't, man. This is a simple problem, man.
So you want to get out of people also.
Because students who would done this problem in 5 minutes.
So more better for you.
No, you can't get problem. You can't get problem. No, you can't get problem as simple as this. You can't get problem as simple as that.
So that's simple.
No, but if you put the is how much formula you use? Go back.
So this
You use this formula A. When you use this formula, you do all this nonsense, you go to the next slide. You use this formula, problem done.
So it's about 5 steps,
Come on, man, let me be reasonable, man.
Sorry, you're being reasonable, man.
I give you 10 marks for that.
Sorry, not be part of it. So you're studying 5 steps and then not reasonable.
But alright. Here we are. We left the problem so simple, you understand me? But I'm going to put 3 compulsory questions.
So yeah, I wrote it down.
Next slide. So initially upright displaces 14,480 tons and has a kg of whatsoever. A weight of 24 to 40 ton is discharge. Discharge. Right? From a position in the low hole whatsoever of the center line to port, calculate the final list. Assume that the KM remains constant. We gotta walk through this problem or we good? We supposed to be good. You understand me? We good, right?
Yes, sir.
Good. It's like it's the same thing we're doing, but we just taking away the weight. That's the way that's discharged, we need to move that. Right? Good. And I realized that some students had a problem understanding that the port moments should be equal to the starboard moments. Right? The port moment, that's the only way we can get balance. You understand me? Is if you cancel out this, it's if your value, if you go up on a seesaw, for the seesaw to remain straight. Everybody gotta be, the person sitting on this end gotta be the same weight as the person sitting on this end. You understand me? Now moments basically is calculated when a beam, you understand me, is rests on a pivot point. You understand me? You put weight on one end or you put weight on both ends, it's going to cause the beam to bend. They call it bending moments. You understand me? And you need to calculate all those, you need to calculate the moments. You need to calculate the moments based on the center, based on the distance. Right? Moments has to do with weight and distance. You understand me? Of course the beam is going to react different the closer you come to the pivot point of the beam. If you guys understand what I'm saying. The beam is going to react differently. And that's why in construction when they talk about columns got to be a certain distance so when you do your beam above, you understand? You don't want to put, the farther out you put your columns, you understand me, it's less weight the beam in itself can take it. You understand me? The closer you put the columns, that column and that column, the closer you put it, the more weight this you can take. Right? So that when we think about moments, we need to think of it like that. Right? So in this question is for a ship to be upright. You understand me? Obviously, the port moments has to be equal to the starboard moments. Right? A ship that is listed will have G off the center line, by a distance of GGH. Right? As shown. We establish, you see, we know this diagram here. We have no confusion over this diagram here anymore. None whatsoever. Right? Answer me, man.
Yes, sir.
Good. So consider the formula now. Consider the formula for a ship of weight GGH is equal, you know this here also. Right? Now what they're saying, I think we had some students who had some issues. When we speak about the triangle, students understand the triangle? So the triangle is basically this here. GGH is equal to WG multiplied by W. means now that if we want to find WD, WD is going to equal to GGH divided by big W. If you want to find big W is equal to GGH divided by WD.
Okay, fine.
Yeah.
You guys understand? When we were speaking about this triangle here, you understand me? You guys understand what we were speaking about here, right? Or is now somebody here some revelation to that?
Yeah, so now we make it more clear,
I
man.
don't think so.
You understand me? So just fit it like this here. And when we transpose in, sometimes I give you all the GGH. You understand me? You need to find the rest. Sometimes I give you all these two here and ask you to find this one. Give you all these two here and ask you to find this one. Or give you these two here and ask you to find that one.
Sir, in this case with this triangle, right? Because WD is supposed to be moments. So if we have the GPG, we're supposed to just find moments.
Correct. Right? So in this case, what happens here is that they say that port moments must balance with starboard moments. And all what they did here is that they say if this is GH is equal to WT divided by big W, right? This is GGH over 1. This is actually GGH over 1. Right?
Yes, sir.
Because 1 into anything is the same as what it is, right? So all what they did here is they cross multiply. So it's going to be GGH multiplied by big W is equal to WD multiplied by 1. Right? Anything multiplied by 1 is the same thing.
Yes, sir.
Right? So basically it's GGH W is equal to small w D. Right? And this is how you get port moments is equal to starboard moments. Because this here is a moment and this here is a moment. Because we know that GGH is a distance. We know that GGH is this distance here. And we know that this big W here now is some displacement. We know that this W here is some weight. And we know that this D here is some distance. So it balances out, right?
Yeah.
Y'all know understand what we were speaking about, or students understood before?
No, we are.
No catching this particular part, so.
Alright, good. So we can move on.
Sir, wait, I got answer. I gotta get clarification. I gotta check that answer. Yeah.
Good. So this is GGH big W, represent the listed moment that the ship initially has, and WD represents the moment required to equal GGHW if the ship is to complete upright. Right? So we consider the example. A ship has a displacement of 12,000 tons and is initially listed at 2 D. It's like giving you the timetable. The problem is giving you the timetable. Right? If the kg of the ship is 11.60 meters and the km is 12.00 meters, how much ballast water must be transferred from starboard side ballast tank to a port side ballast tank through a distance of 16 meters? And we know about ballast water. We know about ballast tank because we did it. We discussed ballast water, we discussed ballast tank, we know what ballast water is. We don't know what ballast water is. I told you guys that the ships has ballast tank, and in order for the ship to be stable and balanced in the water, it needs to carry ship water, it needs to carry salt water in those tanks. However, whenever you have cargo in the tank, you empty the ballast tank because the cargo in the tank is going to provide the weight for the ship to be submerged in the water so it can remain stable. As we empty the cargo, we need to refill with ballast water. And as we load the cargo, we need to empty the ballast tank. We spoke about this here, man.
Yes, sir.
Right? So the thing is what I want you to remember. I don't want students when they see ballast tank to confuse them. It means nothing to the problem, really. Right? Ballast tank means nothing to the problem. If I move the ballast tank, it doesn't help the problem. It doesn't take away from the problem. It doesn't add to the problem. Right? So let's go to our solution. Alright. So they would have given us enough information that we could have calculated the KM and calculated the KG. Well, not calculate the KM and the KG, calculate the GM. Because in the problem, they give us the KM and they give us the KG. They give us those in the problem. No, because they give us those in the problem, we were able to calculate the GM, right? But they give us tan theta. They say tan theta is equal to 2 degrees. You understand? So because tan theta is equal to 2 degrees, it's easy now for us to calculate the GG. We use the same triangle here, we use the same triangle, and we substitute, and we will eventually be able to find our GG. Right? Go to the next problem. What does it say? G is arm the center line to starboard by some distance. Right? Required port moments to counteract. Right? Must equal initial starboard listing moments. Right? So we have our GGH. We just calculated GGH. We know the displacement. They give us the displacement in the problem. The W, they didn't give us the W. I think the problem asks us to calculate the W. They give us the D. The D is 16 meters. Right? But they give us the distance. Distance is 16 meters. Basically, multiply this by this is going to equal to this. Right? A letter multiplied by a number, you can't really do nothing with it. Right? So that's why they get 16 W. Right? And if we want to, if we have 168 is equal to 16 W. Basically, we remove the 16, we say 168, right? Over the 16 is equal to W, because we want to make W the subject of the formula. Right? Because it's basically the same thing. Let's say the W, let's say this W, it was this W here, you understand me? And then we had, let's say it was this here, right? Multiply by this. What we need to do was transpose and make this here the subject of the formula. Take this here, bring it here. I can understand my son, whenever he's multiplying, and you want to make something the subject of the formula, he needs to divide. But whenever you're adding or you're taking away and you want to make something the subject of the formula, you need to move it over the equal sign. We know this here, right?
That's right.
Good. So we understand how this W became the subject of the formula. So what we need to do is that 10.5 tons needs to be transferred for the ship now to return, or to cancel that 2 degree list, you understand me, and return to the upright. Return to the upright. You guys okay there?
Yeah.
Good, next slide. Alright, so we know this here, right? Final kg is equal to the sum of moments above the keel, right? Divided by the final displacement. Right? The GM is equal to the KM minus the kg. Next slide. GGH is equal to GM final. Slide. Right? Now ship displaces 8,000 tons, kg 7.60, and is initially upward. And the cargo is warm. And this is where I believe students have most problems. Setting up the table. Right, so let's see how we can set up this table. So reloading cargo and redischarging cargo. It's important that we pay attention to the discharge of cargo. Right? Because the discharge of cargo, we need to put a minus sign on the discharge of cargo. So next slide. Alright, so this is the table that the first weight is 80. Not 80.
8,000.
Right? And then we load 300, then we load 250. Right? We discharge 50, and then we discharge an additional 500. Right? These KMs were given. Right? KMs is distance. Right? W, or the tonnage, is the weight. The weight by a distance is going to give us the moment. If we multiply this here by this here, we're going to get this here. This here by this here, this here, this here, this here, this here. This is going to give us this. This here by this here is going to give us this. However, what we didn't know is that we didn't know the kg here. You understand? So, mathematically, if this here multiplied by this here is going to give us this here, it means now that this here, you understand me, divided by this here, you understand, is going to give us this. Right? And that's the reason why we get this value here. So, this was one of the problems that we had in issues with. right? Because what they end up doing is end up using back this displacement here only. The previous problem, what they did is that they took this displacement and added to all of this here, and then get this, and then use back the value here. Right? So go back to the problem. A ship displaces 8,000 tons, right, with a kg of 7.6 and 7.6 meter, and is initially upright. And is initially upright. The ship is upright. You understand me? So if the ship is initially upright, you understand me? It means that that there is its final displacement. That 8,000 tons. You understand? Because it is initially upright. Right? The others, the following cargo is work. Right? That cargo is work. Calculate the final angle of list on completion of the cargo if the km for the final displacement is 9.336. Go back to the table. So when we divide this here, 8,000 divided by this here is going to give, no, this here, sorry, this moment here divided by this 8,000 here is going to give us the kg, right? So we use our kg here, right? And we minus it from our km, and it gives us the GM. It's like this. Now, this here is what I think some students got confused here also, right? Initially upright. If we're initially upright, there is no distance on the starboard side, there is no distance on the port side. Right? There is no distance off, just a moment. There is no distance off of the center line, whether port or starboard. So that's why this here is 0. Yeah.
Sir, looking back at the question, I also observed that the amount that we loaded, we discharged the same weight that we loaded. Could I also?
Let me see, go back, no, let's stay right here.
If you take the question.
So this here is 550. Well, there's a good point, right? Because this 300 plus this 250 here is 550, and so we load 550, and then we go on discharge. 550 also, right? So that's a good observation. So basically, it's like we didn't do anything. You understand? The same load that we put on is the same load. We take off, right? So that's a good observation. Right? So with this 8,000 here, there is no movement. So 0 by the 8,000, 0. So there was no movement on the port side, there's no movement on the starboard side. Then we went and loaded 300 tons. And the distance that we loaded 300 tons, there were movement at 6.1. We multiplied the two, and they say in the question itself, go back to the question. In the question itself, there's 6.1 meters to the port center line, right? So it tells us where we got it. It tells us where we need to put it. Right? So we put it at port. This multiplied by this here goes at port, right? Now this here, this 250 multiplied by this distance here. That's how we loaded it at starboard side. This 50 here multiplied by this here. This was loaded at starboard side, and this 500 multiplied by this here. It was loaded on the port side.
So the
right?
the 15 is supposed to be on the port side. Into the question, sir, if you go back into it.
Go back to the question. The 50 from the port side.
Yeah, the table incorrect from when we do it.
Yeah, true.
So the entire question incorrect when I go over it.
And the 500.
The 500 so we're on the port side.
No, but it's the same thing. They don't be the same thing. If we put this here, and then we take this here, 2300, calculate it now.
No, it's not the same thing.
It's not the same thing. It means that this here, this answer here is going to be here. Right? When we cancel out, it means that the port would have turned 0 and the starboard would have left with a value. All right, you're wrong. No, calculate this here. This here plus this here. 1830 plus 230.
2060.
2060. And 1900 plus 2300.
4200, sir.
42, how much?
4200.
4200. This here, 2016 minus 1 0 0 0 0. Port side torn 0 0 0 0. Then we take the same 2060 minus it here from this here. Much we left with?
2140.
2140. Right? So it means that it should have been 2140 over here. But what the problem ends up doing, like you see the mistake. The problem, because they put in wrong value, not when a wrong value, correct value, but they just put it wrong on the table. Right? We were end up with some movement or some movements at the forward side, but it should have been on this, it should have been on the starboard side. Right? That's another good observation. Right? So it should have been on the starboard side instead of on the forward side. But I realized that some students didn't understand what we were doing here with these colors. Right? But I hope no, because I spoke about canceling one side. Right? And when we cancel one side, we turn this side here to 0. Basically what we did is that we took this here, put a 130.0 minus it, 0 0 0 0.0. And then we took this here, we take the same kind of 130 minus it from this here, and then we end up with this here. Right? So we have a moment on the forward side, but we had nothing on the starboard side.
Yeah.
Right?
So now it's nothing.
So you guys understand what we did? You guys understand what we did there, right?
Yes, sir.
Next slide. So calculate the final list, right? So we have the final list here as this here, GGH, GM final, right? And then we have the 0.25. We know how we get the 0.25, right?
Yes, sir.
We know we get 0.25?
Yes, sir.
Everybody? That's gone up. We know how we get the 0.25.
Yes, sir.
Go back to the slide. So basically what they did is that they divided the 8,000 divided by the 2,000, right? So if we say 8,000 divided by 2,000, and this is one of your colleagues, I can't remember the guy's name, right?
Sir,
Mm-hmm.
in observation that they put the wrong values, then we would have a different.
Yeah, different.
Correct. Yeah. Right? So when we divide 8,000 by 2,000 by 8,000, sorry. 2,000 by 8,000. The maths is right, 0 point something.
0.25.
0.25. Right? And why we did that? If we're saying that weight multiplied by distance equal moments, right? Weight multiplied by distance equal moments? Yeah, weight multiplied by distance equal moments. Then distance is going to be weight divided by moment divided by weight. It means that this moment is 2,000 divided by the 8,000. Right? And it's going to give us 0.25. So go back to this slide. Good. So we understand how we get this 0.250.
Yes, sir.
So we are already calculated our GM already up in the problem. Right? So we know that GGH, which is this here, divided by GM final is equal to this here. And then we do our second function, and the answer should have been Starboard. Well, the thing to this here would have probably been wrong answer. Right? But let me take it that every single thing that they did before there, it was right, and this here would have been our answer. Guys understand?
Yes, sir.
Do you need to work any more problem?
No, sir. I'm tired.
Well, we can come next week and we can.
Yeah.